Today we're going to graph systems of inequalities. That means two equations on one graph. Here's a review from yesterday, just one inequality on the graph. You start with the y-intercept, which is positive 1. From there, the slope is positive, so we're going to go up and over instead of down and over. 2 over 1, so we're going to go up 2 over 1, which is right here. It is only less than, it's not less than or equal to. That means it's just a dashed line, not a solid line. And less than means we're going to have to shade the region below the line, not left of the line. It's y is less than this much, and y is the up and down direction. So if y is less than, that means y answers are going to be below. So we shade it like this. All right, there's your quick review from yesterday. Now I'm going to add a second equation to this. Sorry, I keep saying equation. Inequality. Equation means there's an equal sign, and inequality means there's a less than or greater than. If we add a second one to this picture, let's say the inequality y is less than or equal to negative 2x plus 5. That'll give us two lines or two dotted lines on the same graph, just like we had on the last test. On the last test, we wanted to know exactly what was the point where they intersected. What point satisfied both equations? Well, now we want to know which region satisfies both equations. What do I mean by region? I mean this. When we have two lines that cross, it makes essentially 4 different regions. And you don't have to number them in that order. You could number them however you wanted to. I'm just trying to point out the fact that there's 4 different areas here, 4 different regions, and only one of them is going to get shaded when you have two inequalities on the same graph. Let me show you with this example. Y is less than or equal to negative 2x plus 5. If we graph that, we start at 5. 1, 2, 3, 4, 5 right here. Our next point is going to be down and to the right because it's a negative slope, so we have to be down and to the right. How far down exactly? Down 2 and over 1. That puts us right here. It's less than or equal to, so now it's a solid line because we can include the points on the line. And we have to shade the region below that line because it's less than, and anything below that line is over here. All right, so maybe you could tell from all this chicken scratch that we have 3 out of the 4 regions shaded. The only region that's not shaded is region 1. We have shading going on over here in region 2, we have shading down here in 3, and we have shading over here in 4. So how do we know it's the right answer? Because I told you there's only going to be one right answer. You can only pick one region, and right now we have 3 of them. Well, you have to pick the one that both lines have shading going on in there, which is kind of hard to tell that the answer is region 3. So I'm going to shade it a little more neatly. See if that helps. I will shade this inequality right here going like that, and I'll shade this equality going in like that. So the first one was this line here. It was below. Oh, no, that was actually the second one. Sorry about that. Well, I've kind of erased a little bit much here, but I think you get the idea of what's going on still. So our first inequality that I did was the dashed line because it was just less than. So it was actually this one. And we were less than that, so we were shading this region here. We were shading regions 3 and 4 for the first inequality. For the second inequality, we were less than the solid line, so we were shading this area over here. We were shading areas 2 and 3, 3 being the one that got shaded in both. So now maybe it's a little easier to see that this region here, region 3, has the shading going in both directions, one for this, one for that. This region over here, region 2, only has the shading going that way, which was this line. And region number 4 over here only has the shading going this way, which was that line. So you have to pick the one that has shading from both lines and then erase the other shading, or just don't even draw it in the first place. And that would be your answer. You would shade the bottom region, which I'm calling 3 in this example. So that's how you do it. Same exact techniques as yesterday, but now you have to shade 2 inequalities on the same graph and only keep the region that is shaded twice.